everyone, we're going to solve the equation on the interval 0 to 2 pi. We have sine of theta, cosine of theta equals square root of 2. So we have this in sine and cosine is linear in form. One way to solve this is to just square both sides and then solve that way. But you have to check all your solutions. So we're going to use a different method that you usually need for your IB exams. So in our case, our A is 1. It has this form. If this was C, let's put this as C. This is your form it has. So that means your A is 1. I'm just going to put a 1 there. Sine of theta plus 1 times cosine of theta equals square root of 2. I'm going to draw a little graph here and see what it looks like. So it's not drawn to scale or anything. This would be your A, B, and C. So in our case, our A is 1, our B is 1, and our C is square root of A squared plus B squared. So our C equals square root of 1 squared plus 1 squared, which equals the square root of 2. So the trick here is to divide everything by square root of 2. What we want to do is use our sum and difference formulas, namely this one, to help us solve. When you first learn this, it kind of goes slow, but once you get used to it, it actually goes a little faster than trying to square both sides. So it's just a little scary when you first do it. So if we divide everything by square root of 2, each term, and I also can write this as, if you rationalize the denominator, that's going to be square root of 2 divided by 2 sine of theta plus square root of 2 divided by 2 cosine of theta equals 1. So that's our new equation just by dividing everything by my C. All right, now that we have that, we have to make another angle. So we only have theta, so we need another angle. So I'm going to use cosine of phi. Now, if you look at this angle here, cosine is going to be adjacent over your C. So that's going to be 1 divided by square root of 2, which equals square root of 2 divided by square root of 2. And your sine of phi equals your opposite, which is your B, and that's going to be 1 divided by square root of 2. So that also equals square root of 2 divided by 2. It just should be 2. All right. That means this angle equals pi divided by 4. All right. Now that you have this, we can write this as a sum and difference of our angles. So you copy down sine of theta. All right. Square root of 2 divided by 2 is going to be here. That's it's kind of hard because they're both the same, but that's going to be cosine of phi. Then you put your plus, and then we have cosine of theta. And then this number here, square root of 2 divided by square root of 2 is actually sine of phi. This is actually theta here. All right. And this all equals 1. So all I did was substitute these two numbers for these angles here, or the trig functions. Now it has this form, so I can write this as sine of theta plus phi equals 1. But your phi is pi divided by 4. So what we really have is sine of theta plus pi divided by 4 equals 1. So now all we have to do is solve for theta. So sine of theta plus pi divided by 4 equals 1. Now we're going to let this be alpha, so sine of alpha equals 1. That means alpha is going to be pi divided by 2. We want this argument to equal pi divided by 2. So you set it equal to pi divided by 2. So you have theta plus pi divided by 4 equals pi divided by 2. All right, so theta equals pi divided by 2 minus pi divided by 4. We're going to get our common denominator, which is 4. So multiply this by 2, multiply this by 2. You're going to get 2 pi minus pi, which equals pi divided by 4. So that equals your angle. And that's it. Thank you. Have a nice day. Bye-bye.